This is the video for section 4.1, and it's about angles. And so this is the theory video. So what I'm going to go over is what an angle is, and what positive and negative angles are, and why the domain of angles is minus infinity to infinity. I want to say what an arc of a circle is, and I'm going to include circle formulas because we're going to need those. And then I'm going to talk about what radians are and what arc length is. And then we'll do some practice problems in another video. Okay. So again, here's an angle. You just take a point and then take two lines coming out of that. This angle is theta. Again, this is a Greek letter. It's often used for angles. You'll see it a lot. It's the Greek letter theta. Okay, so if I go this way, so that's counterclockwise, theta is greater than 0. This is called the base. So if I draw my base here and go in that direction, measure in that direction, I'm going to have a positive angle. So here's a different example. Same angle in the sense, it's theta, but we're going to measure it thinking of this as the base and measure in this direction. So we're measuring clockwise. And so our angle is going to be negative. So negative and positive for angles has to do with direction. Now, where our angles we're going to imagine them living is on the xy plane. So if I go and make an angle in this direction, my angle theta is going to be positive because I'm going counterclockwise. And if I make an angle in the opposite direction, there's my base, again using this as the base, but go in the opposite direction, then this angle theta is going to be less than 0. Okay. So what I want to do next is talk about how angles can be any side. And it's basically in how we measure them. Okay. So, here's an angle. I'm going to start here. X-axis is my base, and this is almost always going to be the case. And I go this far. Let's say that I go this angle here then would be positive. And notice at this point, it's hard to think of this angle as part of a triangle. Maybe it's part of a square or something else. Okay. Now, if I go this direction, I have a different angle, and that's going to be less than 0. So remember that there's 360 degrees in a circle. And I'm going to say that this angle theta, here I want to use I'm going to use a phi. So that's what I'm using is phi for the other angle. So let's say that theta is equal to 225 degrees. So that's 90 degrees, 90 degrees, another 45 degrees. That's 225. Then phi is going to be 360 degrees minus 225. Sorry, that's the other way around. Well, you'll get to me. It's going to be minus that. So it's going to be minus 336. That's going to be 135. So the angle would be minus 135 degrees. Okay. So if I measure it this way, 225. If I measure it this way, a minus 125, because I'm going, that arrow is important. That arrow tells us the direction we're going in. Okay. So hopefully that explains how an angle can be positive and negative. But here I want to show how theta can be greater than 360 degrees. And I'm going to think of theta as 752. Okay. Now notice, if I go around once in the circle, that's 360. If I go around again, that's 360 times 2, or 720. So 750 degrees would be I'd go around the circle twice, and I'd subtract, and I'd get 32 degrees. So I'd go another 32 degrees, which is going to be about there. So that would be my angle theta equaling 752 degrees. Now the difference between theta equals 32 degrees is you haven't gone around the circle. And theta equaling 752 degrees is I've gone around the circle twice. That's 720 plus another 32. Okay, now what this means is that angles are dynamic. That means there's a motion that's implied, and that's the best way to think about them. Okay, so I'm going to do a negative angle. So let's say we do negative 752 degrees. So I'm going to go in the clockwise direction. There's 360, 720, and then another 32. So again, I'm going to indicate the direction, and that's going to be 752 degrees, but in the negative direction. Okay. So minus 1100 degrees, 1110, let's say. How do I interpret that? Well, I got to figure out how many times I go around and how much is left over. So obviously, twice is 720. So let's look to see what 3 times 360 is. And I'll do the math for you. That is going to be 1080. So minus 110 degrees. I'm going to subtract the 1080, or add it, I guess. And I'm going to get back minus 20 degrees, minus 30 degrees. So what that means, it's I go around 3 times. So I go around once, twice, 3 times, and then another 30 degrees. That angle is going to be 1,110 degrees. Okay. Okay. So again, because of this, if I take any real number, I can think of it, any x is an angle. No restrictions. So that would mean my angles can be between minus infinity, infinity. And I just have to count how many times I've gone around the circle. Like here, I figured it was shaped. We'll do some examples of that. Okay, so that's angles, that's degrees, that's positive and negative. I want to talk about what an arc length is and some circle formulas. Okay, so here's a circle. Again, we're going to think of everything being on the xy plane with, with its center at the origin. That's the radius. Now, if I take a piece of the circle, let's say to here, so I'm going from here to here, that's going to be an arc. And you usually talk about arc length. And we're going to call that S. So that's an arc of the circle. Now, if this were 45 degrees, so I'm going to say, how long is S? And I'm going to say, let my angle be 45 degrees. So we're going in this direction. And I'm looking at S as the arc defined. I use the word subtended by 45 degrees. So that's going to be key. Now I know my circumference of the circle is 2 pi r. So if I go all the way around the circle, that means that the circle length, if I cut it open, is equal to 2 pi times whatever the length of the radius is. And remember, pi, it's a long, infinitely repeating decimal that never ends or terminates, but we're going to think of pi as 3.14 as an approximation. So a circle is going to be about 6.2a radius. So if my radius equals 10, then the circumference, the length around the circle in one trip, would be 2 pi times 10. That's 20 pi That's going to be 20 times 3.14, and that's going to be about 62.8 degrees. I mean, units, whatever that is. Okay, so back to this. I want to figure out what how the length of that arc is. Okay, now let's go. I'm going to go do that. I'm going to draw the picture again on the next page. So here's my circle. My angle is 45 degrees. So I'm going this direction. Here's S right here. So S goes between there and there. There's my radius. How long is S? Okay. Now we're going to leave I'm going to leave the radius blank for a second. So, but what I do know is I do know that 45 degrees over 360, which is going to be 1/8, because we can tell that that's going to be half of 90 degrees. So there's going to be 8 angles, 45 degrees. That proportion, that's going to be 1/8 of the circle, but the arc only goes 1/8 of the way around the circle. So we're going to have this proportion. So the length of an arc to the circumference is the same ratio as the size of the angle is to 360. So here, so I say, okay, well, 45 over 360 is equal to S over 2 pi r. So I divide, take this, put it in my calculator, I get 1/8 is equal to S 2 pi r. So I'm going to multiply both sides by 2 pi r to clear the fractions. And I'm going to get 2 pi r over 8 is equal to S. Well, 2 pi r over 8 is going to be pi r over 4 is equal to S. Okay, so basically the idea is that whatever fraction of the circle the angle makes, that arc length is going to be that part of the circle. Okay, so let me give you a formula. Okay, the formula for arc length. Okay, so we have, again, we need a picture. Here's my arc. Here's my angle. Angle is going to be measured positive. And here's S. It starts at 0, and it goes here. So in other words, it's kind of, this is, if you just want to blow up that part of the picture, here's my angle. That's S right there. Well, the formula is going to be that theta over 360 is equal to S over 2 pi r. And so we can solve for S, multiply both sides by 2 pi r. So I'm going to get, that cancels, so I get S is equal to 2 pi r times theta over 360. And then I can divide 2 into there, and 2 goes into there, 180. So it's going to be theta pi r over 180 is equal to the arc length. Okay, and I'll do some examples of that. So again, the next video is going to be another theory, and it's going to be theory about radians. I think it's better if I do that in its own video, because you might want to watch that more than once. Okay, thank you.